This is the layout that we're going to use. I've already attached all the switches and the potentiometer up here, and I've already got the readout right here. Everything else is loose, but all the holes are drilled, because I'm sure you've all seen holes drilled before. No great shakes there, so I don't think you missed anything. So now let's begin assembly. We'll start with the power supply, the stepper driver, and the plug. Well, the first three things. And I'm going to do some stuff I didn't do in the last one, which is going to simplify the assembly on this. I'm going to make the wiring more like a harness on this, so there's fewer wires. Well, there's the same amount of wires running. There's just less wire in the system, and they all stop at their appropriate places, which makes it easy for the next guy should I part company with this unit, because he'll be able to figure it out much easier. Let's see. This way. Yep, there we go. And that's the way it is. So let's begin. The modular plug is now installed right there, and we're off to the power supply. Power supply is now installed. It is on with 3 screws, one here, here, and here, because I didn't feel like going into this, which is unnecessary anyway. And now we'll move on. And there you go. The stepper driver is now in, so now we have 3 main items, 2 switches, a potentiometer, and the front base. So all we're lacking is 2 more items, and we can begin wiring. So all we have left down now is a step-down board for voltage from 12 to 5, and the step generator. The step-down board is in, and as you can see, I keep insulators on both sides. I really don't like to run the nuts up on these circuit boards, so I keep a spacer on each side. Total of 8 spacers, 4 screws, 4 nuts. And I will do the same for the step generator. I will see you in a moment. Well, I got all the parts in. It's time to wire it up. But essentially what you have here is rudimentary CNC. You have all the players here, except you don't actually have a computer. You're generating a step. The switch is either on or off for direction, and then the enable right here, that just tells it it's okay to run. But it's very rudimentary CNC. You have your stepper driver, your power supply, and your signal. And that's pretty much all CNC is, except you got the signal coming in from a computer under a program, which tells it a lot more than your fingers are going to tell it. But also you're mounting a stepper motor on the x-axis of your machine. So you're on your way to at least a 2-axis CNC by the time you get a stepper motor on the Y. Stepper motor on the Z-axis on these X2 mini mills is requires some work. I have the air shock on mine, the air spring, but if I go to CNC and do this machine and do a Z-axis, it's going to have a counterweight, because I've had trouble with my air shock going bad. The last 4 inches of travel on my current air shock are no more. It doesn't lift those. Gravity lifts without fail. But you need a bucket, a chain, and a rig to balance the pull on the sides for a good setup. Me, I'm going to use 2 gears, a shaft, and a bucket with weight, and make it so it bolts up on the top for a Z-axis. But that's a story for another day. I also put in a hole in the grommet here for the lines to go out to the stepper motor itself. We're going to use the switch but not the light, and this is pretty easy. This here is the neutral. Actually, this is the ground, the neutral, and the hot. And I'm going to wire everything accordingly. The next part of this will all be wiring. Wiring, take 15. Get a pointer. Okay. You can see how I tap into this positive and negative. These two larger wires are my main wires coming from the power supply. I have two smaller wires tapped in down here to go to the step down board. I have two here, and this goes to the display face once I hook that up. Okay, these wires here are all for the stepper motor. I have my big, nasty NEMA 34 400 inch-pound monster, 425 inch-pound. For testing purposes, I put a tape on it so I can see how fast it's moving. Can I get that in the frame? Well, somewhat. My signal wire, the step pulse, is this purple wire. Okay, one goes directly to the face, so when you start it up you don't get no surprise. And the other goes to the switch. This switch is the enable switch, and that goes off to here for the step pulse negative. Actually, what you call direction negative on this. This is direction positive. Now the positive, the 5 volts, horseshoes back to the step generator board along with the 5 volt ground. The pulse out goes through the aforementioned steps. The other end of that is positive. I use ground for doing the actual switching on and off. I'm an old car guy. Car computers have signaled the ground to energize things since they put computers in cars. So I find it just equally as helpful getting rid of a microcontrol unit to doing the same thing here, only with a switch. The next two, this is direction. Okay, this is direction positive, direction ground. And because I use the grounds to energize anything, my direction switch uses the ground coming off of the 5 volt step down board. And that's pretty much the works of the whole deal. I have two wiring diagrams that are almost pictorial in nature when compared to the unit they represent. I've drawn a brand new diagram for this one, and it'll work quite well. Excuse me, I'm going to cough. Pardon me. And that's pretty much that. There's no great shakes here. Like I said, I got the two 12 volts plus and minus for the face, and I have a ground and the step signal for the face. This face here does not will read straight out frequency, but it also has a divider, so I can compensate for inches by knowing that I have 400 step per inch stepper, or 400 step per revolution stepper motors, and a 20 thread per inch lead screw. I can give a divisor that by the frequency out can calculate over time the inches per minute. You can work that out to millimeters per minute, centimeters per minute, meters per minute, or yeah, if you're into the metric thing. I don't do much metric. I do have a few metric items. My test indicator is metric because it was a good price and I can calculate. My 1 to 2 inch Mitutoyo mic is also metric, but it's easy to go back and forth after you've done it for so long. And coming up in the text will be the two wiring diagrams, maybe some other pictures, and I hope you enjoy my mess. But this is the last part of the build. After this is plug it in and use it. I will come back and maybe do a tutorial on this when I set it up. but everybody's is going to be different. You know, it's going to have to do with your lead screw and your stepper motor. You might have 200 step per revolution, 400 step per revolution. There's no telling, and your lead screw and threads per inch. Or you might be running a welding table with this, and you might want to know what the rotational speed. So it's going to come off as RPM, except on a grander scale once you couple in all your reduction gear. And that's about it for this. Now this is the speed. It's a 10K 10-turn potentiometer. These are just single pole, single throw switches, engage and direction. Wiring up this is pretty simple. Because the switches do go bad, I have the switches on connectors. Below the connectors, the top connector on this side is hot, the next is common, and the bottom is ground. And here you can see the order on the power supply. Hot, common, ground, negative, positive. And that's the whole lowdown. So I hope you enjoyed it, and I hope to come up with something new, something a little different, and continue on. I imagine you'd probably like to see a test of the product. So I will indulge you. Let me plug this on in. Yes, I have 110 volts live next to my fingers. But I've been doing this for years and years. And do what I say, not what I do. I don't advise doing it. Now switch power on, and you should hear a hum, that little high-pitched noise. Okay, now I will turn the speed down a little bit. I will engage, and you can see it turn. I can reverse the direction. I can increase the speed. If you want to, you can mess with this resistor right here and increase the speed even more. But I find this pretty much sufficient for the mini mill, because the head starts flopping around on any mini mill worth of salt on this much speed. I'm talking if you're cruising along with a half-inch end mill, look for a head shake at this speed. I dial it down because I like the consistent finish that this gives me by not turning the cranks on such a wet noodle of a machine that I become kind of dependent on it. I like it a lot. And as you can see, the features, this step-down board is the deluxe model with the speed readout, or the voltage readout right here, and you switch it and it tells you your input voltage. It's nice. I like it. My old one was a board that got sent to me from China that I had to solder together. Of course, when I built my first computer, it was an item you soldered together too. But this is my latest toy. I may put it on eBay. I'm not sure. I do have a lot of call for these, but I think I got a use for this one. But like I say, this board right here I've altered. This board is available on eBay, but not in this configuration. I've added these here posts for tying in, and this is different. I use a header connector in the plug-in. I've changed this resistor, or this capacitor, and this is the resistor that goes in line, and the other variable resistor that I yanked out is this one right here. Yeah, you gotta do some calculations to do it, but I sell this board, as I say, pre-soldered, already done, ready to go, along with the matching potentiometer that you see right here. And as you can see, it works. Also, if you turn this thing down slow enough, you can see the frequency pulse coming off the step generator board. And that's pretty much that. If you contact me and we can work something out, I can build you this board, but I won't ship it with a motor because I'm not stocking up parts like that. That's just too expensive for a guy like me to keep around. I don't want to have 100 motors floating around here. Let me turn this off, unplug it. But if I build any of these, it won't be in this chassis. It will be in this one. Main reason is it's easier to work with. The middle is thicker. I can cut it on the mill, and I'm a little bit happier to do that. I don't want to get all involved in hand filing like I did with the other. Anything else here I have to show? Let me see. Oh, I did get a new gizmo. I got me this. And this, which I didn't have before, but I always wanted to have around. And come to find out that when I correct for the fact that it's metric, my setup on my vise is within 2/10, and I set it up with this. I was just curious and about that. I also want to get into some more precision things. And that'll help out a little bit. I'm not selling the fake Mitutoyo, Miluluyu, which sounds like you have a speech impediment, but it's a fake Mitutoyo. Good enough for my work. I'm not doing high precision stuff for NASA. And it doesn't really measure in inches per se anyway. It's just a representation of error. I guess on this setup it will give you a correct measurement under certain circumstances, but you got to be aware of the angle that you're facing your item on. And it comes with a couple of additions, so you can go to the old style beam and magnet bases. But for my purposes, it's good enough. I'm not selling them. I don't tout them. I'm not paid for this little endorsement. This is just something that I just picked up on my own, just because it looked kind of cool, and I'd like to have one. I'd love to have a real Mitutoyo or a stare at last word. I'd throw this away if I had one of those. But I don't, so this is what I keep. This is not a Noga. It is a Noga knockoff. I've never had a real Noga, so I can't say how good it is one way or the other. But if I wind it down, it serves my purpose. And like I say, I'm not here to see how much I can spend. I'm just a guy working out of his home, doing some real minor work that's not all that critical. And I want to touch on some of the more critical things. Also, while I'm at it, there is a change to the kits. I've gone to, where are those?
Okay, here. Yeah, I'm done for now.
A new style of ring, because it's a little less wear on me. I still have to grind in for the magnet, but uses a larger set screw, a little heftier unit. And I do suggest if you use these, if you get a kit with these in it, that you Loctite these set screws.
Basic thing, it's like, then you understand them all.
And did I get any other goodies today? No. Nope. Pretty much it. We're finally out of the tornado warnings, at least for a bit. Welcome to Oklahoma. The land where the tornado is like clouds. I live in a town that was decimated about 7-8 years ago. 2 years after I got here. I came here to retire. Figured I'd work another 5 years after I got here and retired, and didn't really work out that way, but I discovered that I might have left the earthquakes behind in California, but this place had something new. We're currently under flood warning, and have been for about the last week and a half. We have a park at the other end of town, which is the low end of town. I'm on the high end, so I don't really worry about it, but it does make traffic and stuff a little weird around here. Anyway, enough of my little problems. Hopefully you can hear my voice on this camera. I don't have a good voice or a good camera. I have what I have. This is a Sony Megapixel, and the microphone is what you get. If I can't hear myself on it or can't understand it, I put in text. This camera's the bane of me, but one day I'll pick up something a little better. Also, you see on the wall behind me, that's not cracks, that's wire. I have a spool above my light, actually there's a rod above my light that holds several spools, and I go from this side to that side as 18, 16, and 14. Okay, 18 on this side, 16 in the middle, and 14 on the far end, and that's what I work from now. I used to buy wiring harnesses for vending machines that were obsolete, and I went to actually buying new wire instead of repurposing brand new wiring harnesses into something different. A little less time to snatch a foot off of that than go and clip all the zip ties off a harness. But anyway, that's all I have for today. If you bought it from me, we stand behind it.